Area bounded by two functions of y. In this module, you will learn how to find the area between the graphs of two continuous functions of y. Recall that a definite integral from c to d, f of y dy, is the area bounded by the curve of a continuous function x equal to f of y, the horizontal lines y equal to c and y equal to d, and the y-axis. Suppose you're given two curves that represent the functions x equal to f of y and x equal to g of y. The curves enclose some area between them, which can be computed using the concept of definite integrals. Let us see how. First, through the point of intersection of the two curves, draw two horizontal lines that intersect the y-axis at two distinct points, say C and D. Now, if we find the area bounded by the curve of the function x equal to f of y, y equal to c, y equal to d, and the y-axis, and subtract from it the area bounded by the curve of the function x equal to g of y, y equal to c, y equal to d, and the y-axis, we get the area enclosed between the two given curves. If we name the two areas A1 and A2, then their difference represents the area enclosed by the two curves. A1 can be expressed as a definite integral from c to d, f of y dy, and then A2 can be expressed as a definite integral from c to d, g of y dy. The difference of these integrals is equal to the definite integral from c to d, f of y, minus g of y whole dy. This is because the property of a definite integral states that the integral of a difference of two functions is equal to the difference of the integrals of each function. This is the formula to find the area enclosed between the two curves when one curve is to the right of the other. We can also remember the same formula as a definite integral from c to d right function minus left function whole into dy. Let us look at an example. We are given a graph of the functions g of y equal to y square plus 2 and f of y equal to 10 minus y square. We need to find the area enclosed between the two curves. We can see that the graph of the function f lies to the right of the graph of function g. So we can find the area enclosed between them by finding a definite integral from c to d, f of y, minus g of y whole into dy. Now, we need to find the values of c and d. When both curves are functions of y, we draw two horizontal lines through the point of intersection of the two curves to intersect the y-axis at two distinct points. Of these points, the value of y at the lower point represents the value of c, and the value of y at the upper point represents the value of d. Now substituting 10 minus y square for f of y in y square plus 2 for g of y, and solving the definite integral, we get the area equal to 64 upon 3 square units or 21 1 upon 3 square units. This is how we can find the area enclosed between any two functions of y. In this module you have learnt, if there are two functions of y such that their graphs enclose some area between them in the closed interval CD, then the area enclosed between them is equal to a definite integral from C to D, right function minus left function whole into dy.